Welcome to anyone tuning in to video 1 of our Exponents and Logarithms unit for IB Math HL. In this video, we'll be going over 4 questions that help apply knowledge to exam-style questions. Now, let's begin with the first question. Question 1. Given that log base xy is equal to 4 log base yx, find all the possible expressions of y as a function of x. Here, we'll first use an extension of the change of base rule in the formula booklet to get the equation log base xy is equal to 4 over log base xy. We can do this because a logarithm multiplied by the same logarithm with the bases switched around will get you 1. Now that we have a new, more familiar equation, we can use some algebra to get log base xy squared is equal to 4. And simplify this into log base xy is equal to the root of 4, and we'll get 2 different answers. Y can be equal to x squared, or y can be equal to x to the power of negative 2. Find integer values of m and n for which m minus n log base 3, 2 is equal to 10 log base 9, 6. Here again, we'll be using the change of base rule to rewrite the equation into m minus n log base 3, 2 is equal to 10 log base 3, 6 over log base 3, 9. We do this for 2 reasons. First, it's so that we can get the same base on both sides of the equation. And second, it's because we can tell that log base 3, 9 is equal to 2. With that in mind, the equation can be rewritten into m minus n log base 3, 2 is equal to 5 log base 3, 6. For the next step, we'll use the product rule to rewrite 5 log base 3, 6 as 5 log base 3, 3 plus 5 log base 3, 2. We can tell that log base 3, 3 is 1, and therefore m minus n log base 3, 2 is equal to 5 plus 5 log base 3, 2. Hence, our m value will be 5, and our n value will be negative 5. Question 3. In terms of a, the solution to log base a squared log base ax is equal to log base a squared x. In this question, we'll first use the change of base rule on both sides of the equation to get log base ax over 2 log a is equal to log base a squared x over log a. This will be rewritten into log base a x is equal to 2 log base a squared x. Using the power rule and canceling out the extra logs, it'll become log base ax is equal to log base a squared x all squared. Next, we'll take this equation and use the change of base rule once again on both sides of the equation to get log x over log a is equal to log x squared over 2 log a squared. Finally, the denominator log a will cancel each other out on both sides of the equation to get log x is equal to log x squared over 4 log a. Using some more algebra, we can rewrite the equation as 4 log a is equal to log x. Therefore, x in terms of a will be a to the power of 4. Question 4. $1,000 is deposited into a savings account where it gives 8% interest compounded annually. How much is the value after 10 years if the interest is compounded A. monthly or B. instantaneously? For both parts of the question, we'll be using the compound interest equation given to us on page 3 of the formula booklet. This is FV is equal to PV times 1 plus R over N to the power of NT. Here, FV is the future value, PV is the present value, N is the number of compounding periods per year, R is the nominal annual rate of interest, and T is the number of years. When we plug in all our given values into this equation, we'll get 1000 times 1 plus 0.08 over 12 to the power of 12 times 10. This equals 2219.6, which means our future value will be $2,219.60 if compounded monthly. As for calculating interest instantaneously, we'll use the equation FV is equal to PV times e to the power of RT, which is 1000 times e to the power of 0.08 times 10. This will get us 2225.5. And there we have it, 4 exam-style questions on exponents and logarithms. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.